Hello everyone, welcome. I'm Karthik Chandran, the Director of Data Science at Optisol Business Solutions. Um, Welcome to this lesson 2 in our Statistics Demystified series of videos. And in this lesson, we are going to analyze categorical data. So there are two kinds of data, numerical data and categorical data. Numerical data has a continuous can take a value within a continuous range, for example, a person's height, weight, household income, even IQ. They're all examples of numerical data. Categorical data, on the other hand, can take only discrete values. For example, a person's gender, race, eye or hair color, their nationality. Yeah, of course, their shoe size is also an example of categorical data. One thing to pay attention is like a data doesn't have to be numerical and categorical always. Depending on your data analysis, depending on what you're trying to do with the data, you can convert a numerical data easily into categorical data if you bin it. For example, the salary data that we reviewed in our last class is a numerical data, but if you split or if you bin or categorize the numerical data into categories as low, mid, and high, that becomes a categorical data. So this is an important point, that the data doesn't have to be what it is. It doesn't have to be either numerical or categorical all the time. It can be transformed either way if it aids your analysis. The same way, if a data distribution, a categorical data has more than 10 categories, and if it aids in your analysis, those 10 categories of values that the data can have can be viewed as numerical. So that's an important point, that data can be viewed either categorical or numerical or transformed depending on what your analysis requires. So one of the important ways to visualize categorical data is through a frequency table, especially when you have only a data in one dimension. For like what we see here, this is like we are just looking at the salary data, and then if you want to see the frequency of the salaries in these three categories of low, mid, and high, this frequency table is very simple and very useful. On the other hand, if you have two dimensions, let's say you have salary as well as the gender of employees, and then you want to visualize the data distribution across these two dimensions, then we will use this contingency table. Contingency table is quite useful, and then we will be seeing this in different places in our data analysis. But at the same time, it is fairly simple. It is similar to frequency table, where frequency table only deals with one dimension, and then contingency table is used when you want to visualize data across two dimensions. This is somewhat similar to the pivot tables in Excel spreadsheets, if you are familiar with that. So this is the same contingency table that we saw in the previous slide, except what's happening here is, like in the previous slide, the data was just raw numbers, like the actual frequency count of the data under these categories. If you divide the raw numbers by the total, we can get proportions. Proportions sometimes are more useful because it gives you like a standardized display of the data, and then it is easy to visualize and understand the distribution. Categorical data, with the proportions in it, is also used when we deal with probability. We will discuss it more when we get into the lesson on probability, but a contingency table for this reason, it is very commonly used. The contingency table is fairly frequently used. Okay. What's next? Okay, other than the frequency table and the contingency table, a graph, is better. A graphical visualization is always better than tabular visualization of data. And one such graph to visualize categorical data is across, say, 2 dimensions. Like how we did it in the contingency table, is through a segmented bar plot. Even a segmented bar plot has, like the one on the left right here, gives you the actual distribution of data across 2 categories. Like the salary range along one category, and then the distribution of whether female or male employees on another category, you know defined by that 2 colored segments here. So this is a segmented bar plot of the raw numbers. And then if you standardize the same thing into proportions, you'll see a bar plot something like this, which I think may be more useful, and then more it provides a better visualization of the data distribution, in my opinion, than this segmented bar plot, which only deals with, which only provides a frequency count of the raw data. Finally, this is the another way of visualizing a 2-dimensional data, but in this case where one dimension is categorical and the other dimension is numerical. So this plot, this, especially the one you see here, right here, is called a side-by-side box plot. We described the box plot in detail in the previous lesson, that is analyzing numerical data, which is in a previous video, and I'll add a link to it here. Box plot is very useful, while visualizing the distribution of numerical data. And side-by-side box plot is even more useful when you want to visualize the distribution of the numerical data across 2 groups or multiple groups. So this side-by-side box plot is a very important way of visualizing data across 2 dimensions, with the one dimension being numerical and the other dimension being categorical. And then this box plot itself, if you look closely, can give you a lot of information about the data distribution across these 2 groups. And then these kind of visualization will give you a lot, will help you tell the story of your data analysis a lot more so than just numbers in tables. Okay, so the categorical data by its very nature is there's not a whole lot of moving parts, but categorical data or categorical feature in our data analysis is very important, as important as numerical data in our analysis. And learning to how combine these multiple dimensions of categorical and numerical data of a particular data set in your data analysis is very important. So please, go through these, these tabular representation, and then this graphical representation of data, categorical data that we have just reviewed here, and then as much as possible internalize it, so that when you see a new data set, and then with different kinds of data, features, then you will instinctively know how to visualize and analyze it. I hope this video has been useful, and I will see you again in a further video. Thank you very much.